Hello guys, hope you all are doing well. So in the continuation of the previous game series, we are solving the second way of 1997. So today we have few questions. Then in the next video, we will complete this 1997. Then we will start 1998. Okay. So without wasting time, we will see the question. Calculate the time required to calculate the moisture content from 0.66 to 0.25 kg moisture per kg dry air. So they have given the so we will draw x1 directly 0.66 and x2 0.25 because it is kg moisture per kg dry solid. Okay, if it is kg moisture per kg wet solid, then it will be x, small x. Drying rate is given x less than 0.3 and x greater than 0.3, and x greater than x will be the critical moisture content, xc is equal to 0.3. Below this it is going linear, see 0.0015x, that means this is the rate 0.0015x. Okay, linearly going with the moisture content, and this is the constant 0.00045. Okay, so very end x is the kg moisture per kg dry solid. Okay, dry area is this. Okay, so everything is given in the question. We have to put everything in the formula. So for a constant rate period, this is the formula. Okay, if we will put the value Tc is equal to Ls, we have given 0.025 meter square per kg dry into 0.00045 0.66 minus 0.3. Okay, so we will get, this will be moisture content will be in kg moisture per kg dry solid. So dry solid and dry solid will cancel out, meter square sorry meter square and rate will be in kg moisture meter square second. Meter square and meter square will cancel out, kg moisture will contain, so second will remain, so it will give 3200 seconds. 3200 seconds. Okay, now for falling rate period, we have a basic equation of filtration. We have a basic equation of filtration, that is this. Okay, this equation we have, then rearranging it, just taking dt from this side and taking nc in this, all remain same. Okay, now nc is 0.0015x, so putting that value. Okay, so putting that value, and ls upon a is constant. Okay, now integrating it, so t is equal to minus ls upon a into 0.0015 dx upon x from xc to x2. Okay, so it will, when you will solve this question, when you will solve this, okay, let's have minus ls upon a is same, that is 0.025 meter square kg dry solid into 0.0015 ln x2 is 0.25 divided by 0.3. So you will get T falling rate period is equal to 4862 second. 4862 second. So total drying time will be Tc plus Tf, that will be is equal to 10.23 hours. Okay, just converted into hours. So this is straightforward question. This is important question. This is very important question. 100 kilomole per hour of feed of composition 0.4 of more volatile product, binary mixture of constant relative volatility of 0.6 is to be distilled in a continuous fractionating column consisting of parallel partial condenser, one plate and a reboiler, from which a bottom product is continuously withdrawn. The liquid reflux from the partial condenser is returned to the plate. Distillate composition xt 0.8 and R equal to 2. Since it is vapor, this will be YD. So I'll write YD. Okay. And we have solved the question taking distillate composition as YD. Okay. What is the slope of operating line of rectifying section and its intercept on y-axis? Okay. Using McCabe-Thiele method, composition of steam leaving the plate and bottom product composition. Okay. So very first we will see the diagram. See, this is plate. If I write it 1, then it will be 0. Not this, it will be 2. That means W and D. Okay. So this is the condenser, this is the plate, and this is the reboiler. So dYd is the product we are getting. Okay. And WXW is the bottom product we are giving. Suppose we are giving the feed from here. Okay. XL. So just equation of operating line. Very first we have to calculate the slope of operating line and rectified section and its intercept. So very first this is the equation. So slope is 2/3 and intercept is this. Now when two streams leaves at equilibrium, we have this equation, okay, where y and x is in equilibrium. So we have relative volatility. Now for partial condenser, yd is equal to alpha x naught 1 plus alpha minus 1 alpha x naught. See, this is yd and this is x naught. If these two streams, one stream and second stream, leaves at equilibrium, then that means yd will relate x naught. Okay, so we will get x naught is equal to 0.4. So we will get x naught is equal to 0.4. Okay. Now material balance over partial condenser. So over partial condenser, see, this is going out, this is going out, this is going in. So Vy1 is equal to dyd plus Lx naught. Vy1, okay. Now dividing V, since C, R upon R plus 1, if I write, R is L by D plus 1. Okay. So L by D, okay, L plus D upon D, D and D will cancel out, V is equal to L plus D. So it will give L by V. Okay, so we can write is R upon R plus 1 as well, which L by V is equal to R upon R plus 1. Okay, so we'll get this. So y1 will be putting all the values, x naught we have just found. Okay, y1 equal to this. Now when y1 we have found, the corresponding composition of liquid composition will be in equilibrium. So x1 is equal to 0.16. Okay, again applying material balance over partial condenser and plate together. So when we will apply the over, now we are, this is going out, this is going out, this is going in. Okay, now so Vyw is equal to Lx1 plus dyd. Again yw is this, xw will be this. Okay, now overall balance F equal to d plus w, and component balance xf equal to f into xd plus d plus w. Oh, xw plus w. So very first thing we have 100 is equal to d plus w. xf is equal to 0.4 into 100, 0.8 into d plus 0.090 into w. So when you will solve this, you will get d is equal to 43.76. Okay, so this is a little bit tricky question. If you are not able to draw the diagram, then it is difficult to solve. This diagram is very important. Okay, this diagram you are seeing, this is very important to understand. Okay, so if you have any kind of doubt in this question, please just comment it below. I'll try to reply as soon as possible. Okay, so this is the simplest question. Just guys, you are practicing, so just practice this question as a practice question. This is very simple. Okay, just a batch reactor, zero order, and liquid reactant is there. So I have told you everything. Okay, so I'll not solve this now. The first order exothermic irreversible liquid phase reaction A, that gives V, is to be conducted in CSTR. The conversion is 0.7 and the reactor is to be operated at 353 for the given data, volume of CSTR and feed temperature. Okay, so very first thing, For CSTR, we have tau is equal to V by V naught is equal to C A naught x1 minus x naught upon minus RA will be K C A naught 1 minus XA upon 1 plus epsilon A XA, but it is a liquid phase reaction, so epsilon A equal to 0. C A naught will cancel out. Volume we have to find. V naught is 0.01 is equal to x1 is 0.7 divided by K is 0.02 into 0.3. So you will get volume is equal to 1.167 1.167 meter cube. Now the important part is the energy balance. Now to find the feed temperature, we have to apply energy balance equation. Applying energy balance equation, and always remember that energy balance equation will always be work if it is dimensionally balanced. We'll see very first, Q input plus Q added from some external source is equal to Q output plus delta H of reaction into XA plus Q removed. So we are not removing the heat, we are not adding the heat. Q input is mCp T minus T reference. So this is T of feed, T minus T reference is equal to mCp T product minus T reference is plus delta H of reaction into XA. Now just see the composition. M is rho into V. Mass is equal to density into volume. So M is, I can write rho V Cp T feed minus T reference minus rho V Cp T product minus T reference. I just took this term is this side is equal to delta H of reaction into XA. Now density is kg per meter cube. This is V naught. Okay, so V naught is 0. meter cube per second. Cp is kilojoule per kg Kelvin, and temperature is in Kelvin. Minus the same thing will come here is equal to delta H of reaction is kilojoule per kilomole of A reactant into conversion, that is unitless. That means V kg and kg will cancel out, meter cube and meter cube will cancel out, Kelvin and Kelvin cancel out. So we have to make kilojoule per second here as well. In this side we have to make kilojoule per second as well, because both dimension on both the side will be equal. So kilojoule per kilomole conversion is unitless, we have to multiply it. Now if I multiply it with Ca0, then see what will happen. Ca0 is 2 kilomole per meter cube. Kilomole and kilomole will cancel out, but meter cube is there, so I have to multiply with V0 as well. So V0 is meter cube per second. Meter cube and meter cube will cancel. So kilojoule per second, kilojoule per second, kilojoule per second, kilojoule per second, kilojoule per second. Now we will apply this equation right now. So in every equation you have to check the dimension before applying the equation. Now we will apply this equation. So pen, okay, so density C, where is the cursor? This is, so density is same, V naught is same, Cp is same. Okay, so V naught Cp, I will take out common, then Tf minus T reference minus Tp minus, that will become plus T reference is equal to delta H reaction into XA into Ca naught into V naught. So T reference will cut out. Rho is 1000 into volume 0.01 into Cp is 2. T feed we have to find. T product we have 353 is equal to delta H minus 50,000 into 0.7 into Ca naught is 2. Ca naught is 2 into V naught is 0.01. So V naught and V naught will cancel out. Okay. 2 and 2 will cancel out. Okay. So TF, if you will calculate 3 zeros, will cancel out 3 zeros. Okay. So you will get 7 5 is 35. Minus 35 from this side, this. Minus 35 from this side, and this plus 353 will go here. So it will give around 35. 318, I think 318 Kelvin is the feed temperature. 318 is the feed temperature. Okay. So hope you understand this question, and before going for energy balance, always check the units. Okay, you have to make the unit equal on both sides, then the energy balance will be equal. A very good question in 2016 GATE has asked that has the answer of 1802, where sulfuric acid and water is mixing, and that question is outstanding for the energy balance question. Okay, so we will see that question as well. So next question, liquid phase reaction, A that gives R, A that gives S, K1, K, oh sorry, this will be K2, K2, K1, K2, and rate of R is this, rate of S is this. Okay, so this is a zero order reaction, this is a first order reaction with respect to A. Carried out in a PFR. Ca0 is this, no product present in the feed. Okay, conversion is, no product means there is neither R neither S. Conversion 80%, that is conversion of A. Exit concentration of R. Okay. So for plug flow reactor having parallel reactions, this is the formula. Okay, wrote it down. This is the formula where psi R upon A is the rate of desired product. Okay, if I have to found, since we are calculating R, that why I have R is up. If I have to find out CSR, then I have to count phi S upon A. Okay. So this means phi R upon A means rate of S minus rate of A. So this will be in plus, this will be in minus. Putting the values and rearranging it, you will get this. Okay, you will get this. Okay. Similarly, for S, for finding the concentration of, you can find S upon A. So it will give K2 upon K2 plus K1 Ca. K2 like this. Okay. So you can find it as well. But our desired product is R. So we will find R. Now, since no initial product is present, so this will be 0. So this equal to minus. I have put it in place of this. Okay, dCA. Now just it is the same equation. Okay, now 1 plus Ca equal to T. This is a basic integration, we know that from the class 12th. Okay, just substitution method. So T, Ca is equal to T minus 1. Put this value. Okay, put this value here. Then C. Now it equal to minus Ca naught CAF 1 minus 1 upon T. I will put dt okay is equal to minus. I have not changed the limit is same. So always remember, when you will put the limit, you have to change the T in terms of Ca, then you will put the limit, otherwise the answer will be wrong. So T Ca naught CAF minus ln T Ca naught CAF. Now if you will put the limit right now, the answer will be wrong. You have to convert this Ta to Ca in terms of Ca. So T is equal to Ca plus 1. Now you can put the limit CF minus ln. This will give 1 plus CAF upon 1 plus CA naught. Okay. On solving this, you will get CRF is equal to 0.83786. Okay, kilomole per meter cube. You can also find CS like this. C concentration of S like this. So CA naught minus CA minus CR. Okay. CA naught is 2 minus CA is 0.4 minus CR is 0.8376. You will get CS. Okay. Now this is very straightforward question, and determine mole fraction of methane X1 dissolved in the determine mole fraction of methane X1 dissolved in the light oil at 200 Kelvin and 20 bar. Henry's law is valid for the liquid phase and the gas phase may be assumed ideal solution. Okay. At this condition, Henry's law constant is 200 bar. Fugacity coefficient of pure methane is 0.90 and mole fraction of the methane in the gas phase is 0.95. Okay, so applying Henry's law, this is Henry's law. Okay, for liquid phase, and putting all the values, you will get x1 is equal to 0.0855. In 2017, there is a question on Henry's law, same. Okay, so so if you have any kind of doubt in any of the questions, just comment it below, and if possible, then subscribe, guys. Okay, and it is just a request, and bye, guys. Take care.